Hi everyone, it's Duddy here from TechFlow. I'm at EduTech 2016 with David, who's from HP for Education. So first of all, thank you for agreeing to do this interview with us, David. Thank you.
Yeah, my pleasure. My pleasure. Thanks for coming.
Thanks. So I guess the first thing we're going to have a discussion about is what is HP doing at EduTech 2016, and what is HP doing to shift the world of education as we know it right now?
Great questions. Great questions. So we're delighted to be here at EduTech, and we're here to showcase really, I guess, the enablement of reinvention that HP is now involved in education all around the world. So here in the stand, you're going to see some really amazing technology, not just around the devices that students will use in the classroom and teachers will use, but also some really immensely powerful new ones like the Sprout by HP. So that's really what we're here to do. Now globally, really interesting story that backs into this is HP has been doing education in our philanthropic arm, that's the charitable arm of HP, for many decades, working with the United Nations. So as of November, when we sort of became a new company in our own right again, we're actually taking that information and learning over decades, and we're applying it into technology and how it's used.
So, awesome answer. So I guess the first we have over here the Sprout, which is, I'm not going to go into too much detail, but David will.
Sure.
So why don't you just give us a brief overview of what the Sprout is and
Absolutely.
how this can shift how we like use technology now, because you have 3D printers and stuff, but
Absolutely.
that prints out 3D. But how do you capture 3D and how do you use these immersive technologies to do that?
Absolutely. So you hit the nail on the head. So immersive technologies are enormously important for the process of industrial design going into the future. So you'll notice a number of the applications here, applications from traditional suppliers of engineering software like Autodesk, SolidWorks, and those sorts of companies we're partnering with this technology. So this is, as you said, an immersive technology, an immersive compute technology. So it takes blended reality, and the goal of this is quite simple. It's to take your creative thoughts and turn them into an expression in an instant. Okay? Absolutely, yeah. So if I walk you through the actual pieces of technology, so we have a very powerful workstation computer. We have here the very nice looking display, and that's also touchscreen. And then here we have what we call the Illuminator. We've given it a name because it has lots of features. The Illuminator has the ability to project the second screen. It has a 2D and a 3D camera. And it also has a downward-facing webcam. And we have a forward-facing webcam here. And then down on the mat, we have what we call our digital canvas. And so this mat was developed, the surface was developed in conjunction with 3M. It is spill-proof. It is scratch resistant, and it's self-healing. So when it does receive little scratches, it actually seals up. And so you're going to find this on 3M, I think, produced floors and laminates because it is that good. This mat also, as you can see, acts as a second screen. And this second screen has 20 points of touch. Right, so a lot of the magic happens here. But it isn't just these independent elements by themselves that make this amazing. It's how we've stitched them together. And that's the really great part. So, shall I show you a couple of things?
Sure.
All right, sure. So, let's talk about how we can take that creative thought of yours into expression in an instant. And a really good example of that is, say, just photo editing, right? So, we're used to cutting out background images and things like that. So, I've just got a web image here. And what I'm going to do is, let's start with that as an example. I open the Create app, and we're going to paste that image in there, and we're going to enlarge that image. And yeah, I'm not sure if you can see that. Yeah, that's fine. We're going to enlarge that image, and then what I'm going to do is I'm going to chop the background out. So instead of you being limited by your skill, we don't want your creativity to be limited by that. So a lot of the work is done intuitively by the device. We're using our hands, we're using our fingers, we're not using a keyboard and mouse. So I want to keep this subject, and that subject, so bride and groom only, and I want to take the background out. So what you're going to see happen is we've lost some of the background. I'll just take that last piece out, and you can see that it's chopped that out. Now we've lost a little bit of the hair and eyes, no problem. Let's zoom in, right? And let's bring back the hair and bring back the eye and his eye too. And we're done. And so we've now got that as a subject in an instant. So seconds of photo editing instead of trying to achieve the same result, carefully tracing. So that's an example. What about scanning objects in? So let's capture some objects into this picture. So we can easily capture in 2D. So what we're going to do is we're going to capture a banana, of all things. So you're going to see that scan, and then we have the object. And what's going to happen now is that object is now stored, and it's going to appear in the image. So we can now manipulate that object in 2 dimensions and add it to our material. So this is applicable in any application. So Office, PowerPoint, you name it. But let's look at some other applications. One of the really great applications is using that 3D technology and that 2D technology to measure things. So we use an application called Size Up. And what this is going to do is it's going to allow us to measure objects, length and width, irregular shaped objects, just by placing them on the mat. So there's a banana. We'll get the length and width of this banana, but we're also going to get all the irregular measurements around that. So we can also place a hand down, and it's going to measure my hand, but we're going to get details. So that's in an instant, right? So imagine the engagement you've got in a geometry class with subjects measuring objects, and it's applicable to all sorts of areas.
Much easier.
Absolutely. I think the real party piece of this device, and we talked about it earlier, is its ability to 3D scan. So we've got 3D capture. You simply click on it. We select a full scan, and here we have an automatic term table. And it gives us all the instructions we need to actually scan into a 3D object that we can edit immediately in programs like Autodesk, right? And it's that design piece that's actually more critical than printing it out, because that design piece means I can take my banana. We're just going to scan a background. So I don't want my, I guess, engineering skills to create the banana lamp of the future for IKEA to be limited by my ability to draw a banana. So I could spend hundreds of hours trying to draw a bad banana in Autodesk. Instead, I can take a real banana and I can scan it in. Perfect. Now I'm left to do what I'm great at, which is the engineering part. And because this scan will be captured in 3D in Autodesk, we're able to actually manipulate that and get a real business outcome. So when I'm done and we start the scan, what's happening is it's making 500 micron measurements that takes into account texture, color and detail, so that this object, once it's fully rendered, we have a workable object.
So it just does it with this?
Correct, yeah. So that's a depth scanning 3D scanner, so by Intel RealSense. So what you can see is the surface of the banana being rendered. We'll do a partial scan because it does take a little while to do this. But what you can see is as it rotates, it's gathering information, taking measurements, and digitizing those in.
You just saw that has stripes on it.
That's correct. So and yeah. So you'll notice that the various bands are actually bending around the curves of the banana. So what it's doing is it's capturing specific information about the dimensions that it's measuring and capturing those.
So I guess we'll just have to wait. Oh, it's nearly finished anyways.
Yeah, it's done.
Awesome.
So do a complete scan. Takes about 10 minutes, so we won't do a complete scan, but we'll turn it over all sides and it will render in all the surface texture. So at the end of the scan, we've got a complete banana.
Awesome. Yeah, I can see this working really well in schools. Like, so say we have because we just printed out these, I think it was like these cranes out of so we had to mold it in Autodesk Inventor and then make it turn it into a printer. But if we had like the tools, so we could build like a person, but instead of we have Lego people, so we could just like scan it on this.
So we'll just finish it there. So it'll do some final rendering. It'll make that a solid object instead of a partial object. But yeah, to your point, so as an industry, and this is where HP are really keen to be involved with schools, we want you to be focused on design the way we know it should be done in the industry. So as I said, this is the IKEA banana lamp that we need to have. So kids can actually do that process, not limited by their skills of drawing a banana, but they can go straight into Autodesk and start putting the wiring in for the banana lamp and the bayonet fitting for the globe. And then, of course, you want to send that to a patents office before you send IKEA your idea. So you might even do a survey of all your peers saying, if IKEA sold banana lamps, would you buy one? Get a sample greater than 30. All of a sudden, you've got a market survey, the actual design, industrial design. And you know what? You could 3D print this at your school, but you could also send your banana lamp design out to an industrial 3D printer, or if you wanted to make it in metal, to a CNC engineering organisation that does that. So there's a lot of opportunity there, but the design work is key. So how quickly were we into that? So I'm continue to edit. So we can take this away, and now we've got the banana, right, which we've started. Now that's a mould. So if we wanted to, we could just use this as an empty hollow mould, take again into Autodesk, and then actually have some banana chocolate moulds, or create some surface objects in an artwork. Yep. But look, I'll show you one we did earlier with a model elephant. Again, really simple. I'm just flicking this in and I'm activating. So that's a 2D scan, and then the elephant in 3D here will open up. Yep, we'll open up the 3D application. And again, we can put this into Autodesk. And HP's worked with Autodesk, AutoCAD, and a number of ISVs, including Adobe presently, because they see great potential for this. So there are plugins for the Sprout. So you can see the surface texture and detail. Now, what if we wanted to remove really quickly the surface texture on this? So we take that out. That's what it'll look like as sort of 3D print without the color. So it gives you a great idea of where you need to go. But that's the point of the Sprout. What I'm doing with my fingers takes an instant, but it's coming from my creative thought and allowing me to just do it.
So I see this, like, this is perfect for schools and like education in a sense, yeah. So awesome. So this is like what Sprout is, I think, yeah.
Absolutely. So one other really, I think, talking to a lot of teachers at the show, imagining this as a teacher's station. So often you'll do an experiment, it could be a physics experiment or something like that, or chemistry, where a group of kids will crowd around the teacher to see how something's done. Now, dissecting a frog was something that a biology teacher, I think, brought up, which, you know, I've had lunch, so I won't go into that too much. But if we're dissecting the frog, the challenge is 5 students will get full knowledge transfer. But what we're able to do here, remember, this is a spill-proof mat, is we can perform that dissection here with a downward-facing camera. We can record the lesson and how to dissect, and the students can see on a digital projector or a TV how to actually do it step by step as the teacher's doing it. So imagine that. You don't have only 5 students getting that knowledge transfer, everyone's participating. Even the kids that aren't in the class can get a video recording.
Awesome. So I think that's amazing for the education can greatly benefit from this. It's awesome. Yep. So I think that sums everything up. The Sprout, everything's like perfect. So no, is it still in dev phase, or is it out to the markets?
So Sprout has been in the market in the US and in Australia for about 12 months now. So this generation 1. What's coming is generation 2. So Sprout Pro, and you'll see some advertising around about that. And we're expecting that in the next couple of months in the Australian market. And that's going to sit in our workstation team. The team responsible for the last 13-year Academy Award winning special effects movies. So that's just, you know, Star Wars most recently, Deadpool, all rendered on HP hardware, believe it or not. So we have this amazing industry experience that we're delighted to start sharing some of that experience in how we use the technology, and it sits in that team.
Awesome. So this has been Dunny from techflow, and we're at the HP for Education booth with David.
Yes.
Firstly, thank you so much for giving us this opportunity to talk to you about Sprout, because I personally haven't seen the Sprout anywhere, so I've been getting a first hands-on experience with it. It's amazing. Thank you again.
My pleasure. Thanks for coming down.
Thank you.
Cheers.
Thank you. Perfect.